Today's video, it's all about melting this scrap cast iron that was given to me by old foundryman. Now what makes this cast iron very interesting is it is expensive, but it's called continuous cast iron. So I'm very interested to see what it's like to melt down and see how soft it is when I recast it. As you can see, they are gravity die casting molds, 2 halves to a mold, and I'll flip over one of them there to show you the other side what it looks like. As you can see, there's a bit of dismantling work needed there because I don't want steel contaminating my cast iron. This is what happens when you use a low quality Allen key to undo the Allen screws in old foundryman's high quality die casting dies. It just twisted and bended. Okay, I've struck my first problem. I suspect that this piece is steel instead of cast iron. So I'll show you a surefire way of finding out. All you do is just drill a hole and see what the swarf looks like. Now, do you see it? That is steel. Okay, we'll try this half of the mould and we'll see what it's made out of. So, can you see the little chips of cast iron there? This is definitely cast iron, so simple to find out. So, why did I think that this was steel? Well, have a look at this. I put a cut in here and the sparks were definitely steel. And the clincher was that one. I cut that back and then bent it. Yep, cast iron doesn't do that, it's steel. So the moral of the story, when you get unknown scrap, test every piece before you melt it, because if you throw a piece of steel inside your crucible and expect it to melt, you'll be waiting a long time. I suspect some of the scrap cast iron old foundryman gave me is ductile iron. Now you watch when I drill this piece, the chips don't crumble, but they come off in one piece like steel does. So you see the chips, they come off mostly in one piece. That doesn't happen with cast iron. But if you're not convinced that this is ductile iron yet, we'll go and put it in the vise and we'll bend it. And now we'll bend it and we'll see how far it goes before it breaks. Yep, it bends. We'll keep going. Yep, just broke. This is the close-up of the broken pieces after I've bent it. You can see where I drilled the hole through it, and it's a lovely grey, dark grey structure which tells you it is cast iron, but this cast iron bends, so it can only be ductile iron. Steel has a very silvery and fine grain structure, nothing like what this is. So I just thought I'd show you this. This is what ductile iron looks like when you break it up. I've never melted down continuous cast iron, so to be on the safe side I decided to use this pattern, which is 22 millimeters thick and 255 millimeters in diameter. So it's going to be a large casting. It's going to cool slowly and the idea is if I don't add enough ferrosilicon, it should be a soft casting because it's going to go into cool slowly. But I don't know, I've got to try it out. Yep, that piece of transformer lamination makes a great shield. As you can see, I splashed a bit and it didn't drop the shot iron down into the riser where it shouldn't be. And at the last minute I thought, I haven't got quite enough metal, so I stuck another kilo in there, just enough. And now comes the most interesting part of making a casting, is knocking out the mould and seeing what we've got, see if it's any good or not. Here is the casting. I've given it a quick wire brush. It's come out really well on this side. Remember not to ram it too hard to get expansion defects, but wait until you see the other side. Have a look along there. Really, that's the worst I've ever seen, this expansion defects. It really pisses me off big time, but it doesn't matter because I'm only using one side. And there you can see the riser, it's shrunk, it's done its job. Otherwise everything worked really well. I never did a wedge test, so what I'm going to do, you can see the metal spilled from there down onto the concrete floor. So it would have chilled when it hit the aluminium just here, and it should be hard as. So what I'll do, I'll break it in half and then drill it. So this is what hit the concrete floor and went over the aluminium moulding box. It's grey all the way through. So the next step, I'll just go and drill a hole through it. Looks like it's top quality iron. This piece came off when I poured the big casting. It was some of what I spilled. It looks like a wedge test, very thin in one place and thicker in the other. And I'll drill this one as well and we'll see how it turns out. Did you see in the last clip how easy these small two pieces drilled? So continuous cast iron is probably one of the finest cast irons you can remelt down. It does give a very lovely soft cast iron. And you can see that piece on the right, that weighs 14.5 grams and it was machinable. So if you want to make small parts, this stuff would be the best cast iron to remelt. But there's only one problem with continuous cast iron. It is so damned expensive. So this is the pile that's left over from what old Foundryman donated to me. Originally it was 197 kilograms. So what you're seeing here is about 150 kilograms. A lot of it was steel and also ductile iron. But thank you again, old Foundryman, for this donation.